UC Riverside pilot turns waste into textile-grade pulp. At the University of California, Riverside, researchers have launched a biomass processing pilot that challenges the assumptions behind traditional pulp production. Housed at the Center for Environmental Research and Technology, CECERT, the system is designed to process agricultural and forestry waste, materials often considered too low value or too inconsistent for conventional mills. Rather than using whole trees or other high-grade inputs, the new approach targets residues like orchard trimmings, crop waste, and forest-thinning debris, feedstocks typically burned, buried, or left to decay. These waste materials are abundant and increasingly regulated due to their role in air pollution and wildfire risk. Unlike centralized, high-capital pulp mills that require consistent feedstock and generate heavy environmental byproducts, this system operates on a smaller scale and closer to the source. This could open the door for growers, cooperatives, or public agencies to process their own biomass on-site or regionally, adding value to materials that would otherwise incur disposal costs. The first commercial partner, the Herd Co., is already working with the facility to turn almond orchard waste into dissolving pulp suitable for cellulose-based fabrics. Additional commercial and licensing partners are now being sought, signaling readiness to scale. CELF Tech, cleaner chemistry, broader markets. The pilot runs on a patented process called CELF, co-solvent-enhanced lignocellulosic fractionation, which separates plant material under milder conditions than traditional kraft pulping. CELF avoids the harsh chemicals and high heat that define conventional mills, cutting energy use by around 50% when processing low-grade biomass. This gentler approach upholds the same standards of product quality. The resulting pulp has met the technical bar for textile-grade dissolving pulp, used in materials like rayon and lyocell. With brands looking to cut ties with fossil-based synthetics, a lower-impact route to cellulosic fiber is gaining traction. The CELF process also avoids producing black liquor, the toxic byproduct that typically demands costly recovery systems and defines the environmental footprint of pulp mills. Beyond pulp, CELF outputs include several co-products with market potential. Purified lignin can feed into bio-based polyurethane foams for construction. The process also produces gypsum, chemically similar to drywall material, and fermentable sugar syrups that can be used in bio-based chemical production. This diversified output helps reduce dependency on any single end market, potentially improving overall economics. In a state like California, where forest management practices are generating large volumes of waste wood, CELF offers a potential pathway to simultaneously reduce wildfire risk, support decarbonization goals, and localize industrial production.